All right, awesome. Well, hi everyone. I'm here with Daniel, and I'm trying to do better than last week, so I remembered to hit the record button at the beginning of the Zoom session, and I'm plugged in here, so there'll not be any issues with power. Yeah, really excited to have Daniel with us because he's been doing a ton of work on ZIO HTTP, which I know is a library that a lot of people are excited about. We did a RC1, and I think next week we'll have an RC2 coming up. So we're almost at the point of a 1.0 and having things finalized and locked down, but we're trying to get the last pieces just right first. But I thought this would be a good time to kind of get together and hear about some of the changes in the latest version and kind of get everyone ready for 1.0.
Yeah, so I was thinking first we could go through the version history of ZIO HTTP since
that's probably a good thing.
Since we copied or acquired the project from Dream 11, so let me share my screen.
Yeah.
Yeah, just a second, I will make it larger.
Yeah.
Not like this. Yeah, so
nice.
Okay. Yeah, so I just went through all the commits in the morning and wrote a smaller list, which are the major changes to the API since last August, basically, because that's when Dream 11 donated this project to the ZIO organization. And the first phase was actually the first release after their last release, which was 2.0 RC11, was 003 because we didn't manage to publish it properly a few times. But really 003 was the first release in the ZIO organization. And at the time, it was already November, and we had more than 150 commits, which were basically changing a lot of things. Some examples, we got added request logging middleware and I think metrics middleware as well. Initial streaming support for the client. The client was very basic in the earlier versions. And so both streaming support were added and a lot of improvements were made on the client API itself. Another client-related change was adding connection pooling. But basically, in all areas of the library, there were lots of refactorings, code cleanups. We started separating Netty to not be part of the public API, so we can eventually have different backends, for example, for Scala native or Scala.js. And and very important first or very important change was the first version of the API DSL or the endpoint DSL that we have today. It was all already added in this first release, and I will talk about this later. And 2 months later, we had a new release called 004 in January. Again, it was 79 commits, continued all these refactorings that were already in progress, some memory leak fixes, which were significant. And but the most, I would say the most important change in this release was a big change in the core data or the core DSL of ZIO HTTP, which was previously one or basically two types, the HTTP and the middleware. And in this release, we changed that a lot. So it was split to HTTP and handler. Middlewares are now into different, we have two different kinds of middlewares, which are not really similar to the previous ones and so on. I will also talk about this in details. And yeah, and the API DSL was continuously getting improved during these months. And we had one more release in March, which again, a lot of commits, but one important one was adding proper multi-platform data support for both uploading and downloading. We finished removing native from all the public APIs, so that's now an implementation detail of ZIO HTTP. Lots of fixes regarding streaming and interruption. And one more change to the previous big refactor regarding middlewares is that in this version, middlewares are capable of providing part of the environment of the inner handlers, which is very useful if you are doing, for example, authentication, and you or when you create some kind of authentication context, you want to provide it to your inner handler, and now it's possible with middlewares. And once again, the API DSL is continuing to improve, and that's I didn't list all the changes to the endpoint API because it was really a lot of work on that. So a few weeks ago, in the end of April, we released the next version, and we decided that now a release candidate 1, and to avoid collision with the previous release candidates with Dream11, we immediately bumped from 0.05 to 3.0 RC1. Sorry for the confusion. The changes between the 0.05 and RC1 are basically the graceful shutdown. So now if you, when you are shutting down your server, it will make sure that all the in-flight requests are properly finished before exiting the process. One more big core level refactoring was the changing of the header model. I will also show that. We simplified the package structure, so in most cases you only have to do one single import of zio.http.everything. Now you can configure things with ZIO's own configuration API, basically. Many more bug fixes. The ZIO HTTP CLI that you could see demonstrated on the ZIO world, which is a very nice feature on top of the endpoint API that provides you a CLI, generates you automatically a CLI client basically for your server. And yeah, that's the latest version right now. But even since then, we already had 34 commits with a lot of issues fixed. Two API related changes. A small one is that this operator, which was the 2 exclamation marks, renamed to root. I don't know. I like the exclamation marks, but for some people that was confusing, I guess. And there is a completely new WebSocket API, which is very nice. I will try to show that as well. And we are planning to do a next RC, hopefully next week. There are still a few pull requests that we have to merge, and there are still a few issues that we need to figure out. I'm not sure how serious they are, because all those issues are actually only happening on the GitHub CI and not locally, which makes it a little bit hard to fix them, but I'm on it. So I think I first want to talk about this separation of the HTTP type to HTTP and handler and so on, because I think that can be confusing for everybody who used the old one. So how should I do that? Let's write some code.
Yeah.
Not here. Okay, I created a debug Scala previously somewhere, but I don't remember where.
Too many files.
Yeah. It must be somewhere. Probably in the test. Sorry for this. I can't see anything because of this presentation mode in IntelliJ. It's too big. Yeah, demo. It's not debug, it's demo. Okay.
Oh, there you go. Nice.
Yeah, so previously we had things like http.collect request, and then we could do pattern matching on Copilot knows how to do that.
And it already knows about the root.
Yeah, surprising. So this is something that you can still do, and it's not different from how it looked like in previous HTTP versions. But if we check how HTTP looks like under the hood, it turns out that HTTP can be three different things. It can be empty, which means that your server is not capable of handling any kind of input, basically. It can be static, which introduces this concept of a handler. So if you have a static HTTP that has a one-to-one mapping to a handler, and I will talk about the handler very soon. But the third thing that you have is a root. And a root is basically defined by a ZIO effect, which produces another HTTP. So what all this refactoring is about is basically separating the request handler, which tells how, for a given request, what kind of response we should produce and how. And it separates this logic from the actual routing, which takes a request and in some way decides whether it can handle that request or not. And if it can handle that request, it gives you a handler. So if you think about all these three type constructors, it's constructing a tree, basically. If you are having roots, those are in an effectual way can lead to another level of HTTP and then another and then another. And eventually it either ends up being an empty or a static. And if it's an empty, then you cannot handle that request, for example, because it has a path that is not something your server supports. Or it can end up in a static, in which case we get to the world of handlers. And if we go back here, we can also write a handler, which has a lot of the constructors that was previous on HTTP in all the ZIO HTTP versions. So for example, one very simple handler is to just always return with a text. Let's try to figure out what type this has. So this is a handler, any nothing, any response. This means basically that our handler is creating a response as a result. Response is an HTTP response. This text constructor creates a response which has status code 200 and the body is a text, basically. But the other type parameters of handler are an environment, an error, and an input. And when we are actually implementing HTTP servers, this input and output is usually request and response. It's any here because in order to return with a response that contains hello world, we don't need any kind of input. We are not using the request at all. We can write other kind of handlers. For example, we can write an effectful handler from function ZIO, for example, take a request. And here we have to implement a ZIO function that produces a result or a response, because in order to, so we can write any kind of handlers. It can be converting them into a string if we want, but once we want to use it as in our HTTP server, it has to be a handler or an HTTP that takes a request and produces a response. So we can just do something like random next string and return that. And now we have something that still doesn't use the request, so that's not that good. Let's say that we are also adding here something from the request. Oh, like this. Okay, so if we check the types of this handler, now it's a handler from request to response, and it still doesn't have any environment or error because it's not needing anything from the ZIO environment, and it's not it cannot fail basically in any way. So as we saw that an HTTP is just a routing that selects a handler, we can write, we have these convenience methods like collect and so on, which are in one step creating both the handler and the routing. But we can do it by hand by creating another HTTP, which let's say does collect handler request. And here we can delegate the request handling to these two handlers based on the method and the path, for example. So let's see this. If the path is /first, then we are selecting the first handler. And if it's second, then we are selecting the second one. Now, if we check the types, it's an HTTP from request to response. And how can we work with this? Let's just, we don't even need a for comprehension here. We can write server .serve. And here we need something that is called an app, which I wanted to show you. So what happens if I write HTTP2 here? It probably just works, except that as you can see, it requires a server in the environment. So let's just try to build this first. Where is my here? So yeah, it says you need a ZIO HTTP server. So let's provide a ZIO HTTP server, like a default one. And that's it. It should now compile. Yeah. So the reason why I showed this is that we can make a little change. It will not make much sense, but sorry about the don't have a good example. Let's say if the method is a post, then we fail with a string. Otherwise, we do what we did. So now if we regenerate the types, now it has a string as an error type. Now the whole HTTP also has a string as an error type. And now we no longer can compile this code. Why is that? Because now it says that we have an HTTP that fails with a string and processes request to response, but it needs an app. So let's check what an app is. This app turns out to be a type alias for an HTTP app, which says that we have whatever environment we are using, but it also says that it's an HTTP that can process an HTTP request to produce an HTTP response, but it needs to be needs the error type to be a response as well. And this is an interesting API choice that I like a lot. It basically says that if your HTTP server fails, it has to fail in a way that we can return this failure to the user. So if you have an incoming request and you do anything and that program fails, you want to fail in a way that produces a response that you can send back to the user. And this means that there are several options here. So one of the options is to just map the error and create a response like this from string. So this is one possibility, right? Okay. Oh, yeah. So now it compiles, at least. IntelliJ is no longer underlining it, so it must be good. Yeah, but so this is a good enough default actually, and we have a more simple way to do the same, which is to just say with default error response. So this will do basically exactly the same as this, I think. Yeah. No, it's not the same because it ignores the actual error to not leak out any information. So it will just return with an internal server error without any body, which is a good default. But if you don't like that default, you can just map error on any level actually. So you can map error on the global outermost HTTP or on the handlers or on any level of these composed HTTP server and convert your domain errors into HTTP responses, whatever way you like. So let's talk a bit about why we did this. Why we did this separation. And the main motivation was middleware application. So I didn't talk about that, but you can compose multiple of these HTTPs. Let's just write another example. So if you have HTTP2 and HTTP3, you can create an HTTP4, which is HTTP2 plus HTTP3. And that means that if the first one cannot handle your request, then it will try the right-hand side, which is like this. Yeah, so now about middlewares. Middlewares are something that you can apply to your handlers and HTTPs, and they modify the behavior somehow. For example, one useful middleware that we can apply with this middleware application operator, I don't know how to call it, is request handler middlewares log request or request logging, sorry. So if you do that, this will automatically log every incoming request with some configuration options, like log the headers, what log library to use, and so on. But the point is that by applying this middleware, we are changing the behavior in an orthogonal way, and there are a lot of different middlewares. One very common one is providing authentication. Like, for example, a simple one would be to check for the basic authorization headers and check the username and password. And if it's not matching to something that we know, then reject the request. So let's try to do that. There are many authentication related constructors here. One is basic auth ZIO, let's say, where you get the credentials and you can write a ZIO effect that returns true if you want to allow this access and false if you don't. So let's say, okay.
That's a highly secure set of credentials.
Yeah, it's actually, I think it's some type, so let's match on it. I don't know what type is this, sorry. Credentials. What is credentials? Oh, it's case class. You name
Is
you
it just
prefer.
the auth.credentials?
Okay. So I don't like passwords, so I just allow myself in. And we don't want to fail, we just deny access to anybody else. Yeah, and of course, if it's that simple, you don't have to use the ZIO version. I just wanted to show that because that's usually what in a real world scenario you would use, because you would do something in an effect here, like ask, get something from a database or a cache or whatever to figure out whether the user and the password is good or not. But let's say that we want to apply this authorization or authentication middleware only to the first and second endpoints, and the third is public for anybody. So you could do that like this, right? This means that apply this out into HTTP2, and then do everything or not care about the out header at all in HTTP3. So I'm not sure this particular example was bad in old ZIO HTTP versions, but it was really easy to write code like this that was not working as expected. And the reason is that it's not. So let's imagine that we only have HTTP and we don't have this separation of routing and handling the request. If you apply this out into this HTTP2, and your username is not Vigo, then it will, the middleware's implementation is that it will ignore your original request handler. It will just return with a HTTP response that contains whatever unauthorized request or something. So that means that you actually handled this I'm trying to come up with a good example, sorry. Yeah, so if you were calling first or second and do this, you get a response and you don't have to care about HTTP3, and that's right. I'm trying to remember what was the original issue, because, okay, I should have come up with an example before the actual Zymposium, sorry. Well, okay, so I think my example is not the good one, but what I wanted to say is that it was possible that, for example, the authentication logic was called in cases when the actual request was not matching the path, or another possibility was that you rejected the first part and you were not even trying the second part. I think this example is not demonstrating that old issue, but there were all kind of ambiguous cases like this. I don't remember exactly, but we were trying hard to avoid them. Yeah, that's where we came up with this separated model of having HTTP and handler. And the most important thing to know about it is that everything that is a request handler middleware. So for example, if we check the type of this one, it is a request handler middleware. Request handler middleware means that a middleware that gets applied to a request handler, which is basically the handler type. It means that no matter where you are applying it, if you are applying it to this handler 2 like this, it will result in another handler. If you apply it to an HTTP like this, it results in another HTTP. But even if you are doing that, you can be sure that it's only affecting the request handlers and not the routing. So if you imagine the HTTP as a tree, this is just a shortcut basically for applying out into each handlers at the leaves of the tree. It don't have any kind of access to modify the routing behavior. And that makes it much more composable and easier to understand what's going on if you are applying it on various levels of the composed HTTP. There are still cases when you want to actually modify the routing. A very simple example is when you are adding trailing slashes or dropping trailing slashes. And there are a family of middlewares called HTTP app middlewares, I think. Yeah, so for example, the drop trailing slash is a different kind of middleware, which is not a request handler middleware, it's an HTTP app middleware. And if it is an HTTP app middleware, it can modify the routing. And dropping the trailing slash is modifying the routing because you have to do it before you traverse your route, basically, because first you transform the request to not have a trailing slash, and then you decide which handler to choose by going through the routing. So that's the difference between the two kinds of middlewares. Another possible HTTP app middleware that we have is called LO and LO ZIO, and those can dynamically enable or disable parts of your HTTP server. So that's also something that needs to modify the routing, because it decides whether that sub route of your HTTP server is enabled or not. And if it's not enabled, then it just pulls it out of your HTTP server. It's converting it to an HTTP.empty. Yeah, so I don't want to talk all the time only about the handlers and middlewares and HTTPs, but that was a very, very big refactor, and I wanted to talk a little bit about it. So, but it's already, I talked a lot about it, so let's go back to the version history and choose some other topic. Yeah, I guess the even more important topic is the endpoint API, which is completely new in the ZIO version of ZIO HTTP. And that is something that lies in the ZIO HTTP endpoint package. And it's a higher level API on top of all this. So ideally, you can even forget about all that I said and express your HTTP server in a much higher level. And I will say, yeah, let's first write a very simple example, and then I will talk about why you will do that. So let's say we create an endpoint, which is endpoint get. Here you can construct a path. So for example, first /string text. I think it's called text. Or I don't know. Let's see an example. Yeah, it's literal. Okay, I remember now. So we need to import stuff from the HTTP codec. So it's a literal string. Okay. Or a string with a name. And then we can call other stuff in this endpoint DSL. For example, we can ask for a query parameter, or not like this, like this. Or we can say that it returns with a example response, which we define here as a case class. And then we can also ask for an input, which can be a JSON body of your post request, but now we are implementing a GET request, so we don't want to do that. And you can also say that you are having a streaming output, for example, a byte stream or a stream of JSON elements or whatever. And you can assign documentation to your endpoint. I don't know how exactly. Yeah, sorry, I don't know the syntax of this, but you can you can attach documentation comments to your endpoint. And let's see why it's not compiling. It's not compiling because we cannot find an implicit value of type ZIO schema for example response. And that's because this higher level endpoint API relies on ZIO schema in order to know the structure of your types that you are either expecting as an input or providing as an output. And one thing it can do with the ZIO schema is to automatically have a JSON codec for your types based on it, but it can also use it to generate documentation, to generate your CLI client. And really this schema is capturing the structure of your type, and it can be used for all different purposes runtime to basically enumerate your fields and constructors and do all kinds of interesting things. So we need to provide an implicit schema for all our types that are used in this level of endpoint API. And the simplest way to do is to derive it with derive schema. There are some cases when you cannot derive it, usually when you are using type parameters and or something that is not supported right now by ZIO schema, but usually deriving it is just fine. And now it compiles. So how to, this is just a description of one single endpoint. We can write another one, like, not very, okay, let's do something else. It's a post with no such parameters, but we are accepting a stream of bytes. And just outputting an integer, which will be the length of the string, for example. So how to specify how to write code that handles these requests? First, there is we can write something like endpoint impl equals endpoint.implement. And as you can see, it knows that we are getting a string and an integer, a string from the pass and the query and an integer from the query parameters. And it knows that we have to provide an example response as a response. So we just have to write this function from name and age to example response. And it can be a ZIO effect, so we can do all kind of interesting things to provide our HTTP response here.
And there was quite a bit of fanciness that went into actually making this seem so simple.
Yeah. Yeah, but really, you just have to write a Scala function that takes the input as properly typed inputs, and you can just return the output, and everything else is handled by the endpoint server. And you can implement the other one in a very similar way. Here, we are getting a stream of bytes, and we have to produce an integer. And fortunately, in ZIO streams, we have an operator for that called run count, which is actually giving a long. So let's just change it to a long, and that's it. And now we can create an HTTP, which is the combination of these two. And the type of this HTTP, or let's call app, is that?
No, it's not.
No, it is. No.
Oh yeah.
No, it is. It is, because it's this
Right.
type
We've
here.
already provided all of our stuff. Sorry, I should have made you show one of the other types before.
Yeah. So it's an HTTP. So it's an HTTP which doesn't have any environment, and it has a response as a failure, and the request is as an input, and the response is a success value. And we can directly use it in the previous way to serve it as a to start our server and serve these endpoints. And what other? So hopefully it's already a good reason to use it, just to have this nice separation of the endpoint specification and the implementation of those endpoints. But it also has other advantages. For example, we can generate, probably not right now, but in theory, we can generate things like open API specification from these endpoints. These endpoints are completely declarative. You can write code that goes through these endpoints and do whatever. And this is how the ZIO HTTP CLI works. It just goes through all your defined endpoints, and it generates ZIO CLI mapping to it, and you can call your server from a CLI app. Or what else we can do with these? Yeah, another important way to use it is to call our server from another Scala program, so it can be used as a client as well. And let's try to do that. So let's say we want to call the first endpoint here. It's just something like endpoint dot apply. So okay, that's not very useful, but we can just call it with the two input parameters that we have here, the name and the age. And that's it, I think. Or not exactly. That's an invocation. And just a second. Let's when I don't remember something, I usually just look up one of the tests. But I also try to keep the documentation up to date, but it doesn't really have anything about this new endpoint API yet. So let's see one of the endpoint tests and see what it does. So it starts something. We have a root, which is the result of implementing an endpoint. And we have an executor. And then, like this. Yeah, here's an implementation, which is a handler. And that's not a good example. Test endpoint. That will be the one. Yeah, so we need an executor layer, which is something that can execute our endpoints. And then, yeah, okay, it was just an IntelliJ type inferencing that this doesn't work, I think, because okay, let's try to compile it and see what is going on. Yeah, I'm missing something obvious here, I think. Because that's, oh, sorry, yeah, we need an executor and, okay. So executor is an endpoint executor. We need a client and an endpoint locator for that. The client is our ZIO HTTP client, which I also wanted to talk about, but maybe we don't have time. But let's
make this the first of a series.
Let's say we have a client. The client is actually what you can use for making requests directly. Like we can do a post request and so on. But we can also use this client for calling endpoints and that way we can provide the inputs as typed values, and we don't have to care about constructing an HTTP request. And the endpoint locator is just something like this. And there is something called middleware input, which is now unit. Or let's see. So once we have this endpoint executor, now we can call the endpoint with, yeah, so the apply function here requires an invocation. Executor like this. Yeah, so now it compiles. So, and then you would get back, I think, one of this type, directly this example response. Yeah. So you don't have to deal with creating the request, constructing paths and query parameters, encoding somehow the input as a JSON or whatever, decoding the response as a JSON. Everything is automatically provided by the endpoint client, and it's a very nice way. So nice way to expose your server's functionality to other Scala consumers. So you can, for example, just put these endpoint definitions into one Scala submodule project and use it from other Scala projects as for calling them, and in another Scala project to implement them. Okay, so what else? Yeah, I don't know, the new WebSocket API is also nice. Do you want to talk about it, or should I try?
Sure. You want to start and I can jump in?
Yeah, so I will try. Try it out. I haven't really used it yet. It's very new. Last week, I think. But I think it works like we start with a
handler.
WebSocket handler.
Yeah.
And we get, what do we get? We get a channel event. Right?
Well, I think there's a handler.websocket, I believe.
Oh, okay. Then that's even better. Yeah. Yeah. Yep. So we have a channel. It just
gives you this WebSocket channel. Yeah, exactly.
Oh, it's even better than I remember. Yeah. So yeah, we have this channel, and with the channel, we can start receiving messages, right?
Yep. The receive all is probably the simplest one. Yeah.
Yeah, and this is a WebSocket channel event. Yes. WebSocket. Is it WebSocket channel? What's the type? Oh, it's WebSocket channel. No.
I think this is. Go to the type alias WebSocket channel. And then I go my own as well.
I see. Okay. Receive all. Here it is. Just okay. I don't
channel
know
event already.
Yeah, this is the one. So let's say we get an event registered.
Yeah, it's a channel event, not a WebSocket channel event.
Channel event. Okay.
Yeah. And then inside, yeah. Now it's right.
Yeah. It's even simpler. Yeah.
And I think
it's even simpler.
Yeah.
And then we can do something like just here we have a 0, so we can log registered, and we can handle unregistered, and we can receive read with a message with read, right? I think.
Yep.
Yeah, and if we read a message, we can also use the channel to send back something, which is can, let's say that we just send back, it is a simple echo server. And that's it. And now VS handler is a handler, the same handler that I was talking so many minutes about. And we just have to add it to our root somehow. So let's say I don't know what the usual way is. Collect handler, let's say. There are many options. We just do this. And what else do we have to do here? We still have to somehow, how do we convert this to a, I don't remember.
We shouldn't need to do anything, because if you do the type of the WebSocket handler, it's just a handler that doesn't require any input.
It requires a WebSocket channel now. I think there is something else to be called, but I don't remember.
Oh, sorry, I'm forgetting. Hold on a sec. Let me look up. too many things. Let's see.
Here's an example.
Oh, to response. To response.
To response. Yeah.
Sorry.
I know. Yeah. So that's it.
There we go.
What happened with this? Oh, now it's another kind of. Yeah. So too many code in one file, but yeah, that's it. Yes. So that's the new way to implement WebSockets, which is very nice. So I think it's almost over 1 hour now. So what else should I talk about? Or were there any questions in the meantime?
Yeah, I was going to say, maybe we should kind of go over questions and then we can kind of save other stuff for later. But let me go through some of the questions from Discord. So when you talk about middleware, there was one question about how can you grab some info in the middleware if you need like a correlation ID or something, which I think is kind of setting us up for the contextual middleware. I don't know if you want to talk about that now or later.
Yeah, so I will just, maybe I will just show the one contextual middleware that we have, and maybe we should talk about it in a different time because it's quite complicated.
Yeah.
But if we go back to our original example, let's say this, and we had a handler too. Okay, so let's say that we also have something like this. And in the handler too, now we no longer create a random string, but we use our out context to create this response. And now we have out context in the R parameter of our handler. And we want to have this out middleware to somehow provide this out context to the handler or HTTP that it gets applied to. And we have something ready to use for that, which is something like request handler middlewares out custom out providing and get headers. There is a ZIO version as well, but let's try this one now. So, oh yeah, I wanted to talk about the headers as well, but now is the time. So we have fully typed header model now, and so we have this headers parameter here, and we can get header by type, and we have in the header companion object all these objects for all the standard HTTP headers, for example, authorization. And if we have an out header, if we don't have an out header, okay, actually we have to return an option context here. So we can just map this and out a match. There are all kind of default authorization methods that we can support. Actually, this is a flat map. We don't want these. And if it's me, then we want, okay, that's not the best example. Let's say password is 123. Now it's a good example. And then we can store the username from the header in this out context. And that's it. Now, if we check the type of this one, hopefully IntelliJ will figure it out. I'm not sure. But yeah, it did. Almost. Okay, so this is quite complicated on the type level, so I don't think IntelliJ can handle it. But other than that, I will show you why I'm saying that by generating the type of this one. Yeah, so IntelliJ is not good with these, but if you are not writing these types and just trying to compile it, it should work. And it should eliminate the out context in the inner handler. And it even works if you are requiring something else, like let's say you require a HTTP client because you want to do a client call as well in your request handler. It will end up with a handler that is like string. So this should compile. Yeah. Somehow it can be. So I'm sure I made some mistakes somewhere. Probably because I have to write some explicit R parameters in some places. I think like this. Yeah. Now it works.
Nice.
Yeah, that's just that. That's another issue. Yeah. So this is because of how because we have it's the similar issue that we have in ZIO with the provide sum, for example, that we have to specify the type that remains there, otherwise Scala cannot figure it out.
So a couple other questions. We can decide which ones we want to do today versus another time. Someone was interested in with the endpoints API. Is it possible to do reverse routing where you format a URL for a given endpoint? I'm not sure that quite makes sense, but
you get so you it's basically like calling or like when it's working in the server mode, just not handling the request, but returning itself, or I don't know. There is definitely no built-in things like that.
Yeah. Okay. Well, maybe that's one that Manfred, if you want to follow up on Discord and maybe provide a little more detail about what you're trying to do there, we can see if we can give you a better answer to your question.
Yeah, definitely.
And then we had one question about, could we show how to write tests for the endpoints? I think you maybe briefly went to one of the test suites, but maybe that's the best place to look for that.
Yeah, so just very quickly, the simplest way to do is once you are converted your stuff to HTTP, which is possible for even if you are using the endpoint API or if you are using the low-level one. You can write in your test, you can do something like run ZIO and just pass in a request, and you get back a response. So that's one way to test this. Of course, then if you were using the endpoint API, now you have to pass a request by hand, which is not that nice. I think we could, and I think we should have a test endpoint executor, which is like the endpoint client that I showed somewhere, but designed for testing. I don't think we have that now, but I think we should.
Good feature to add. All right, cool. Well, I think we're at time here, and I think those are at least all the questions I saw. Definitely, if I missed something for someone, please post on the Discord, and I'm sure we're going to do some follow-ups on these. I don't know if we'll do it next week, or maybe we'll do it like once we get a 1.0 version out. But we know people are interested in ZIO HTTP, so we're going to have lots more content about it. And after this, we'll kind of build some stuff with it and do some cool stuff. So thanks, everyone. And thank you so much, Daniel, for joining us. That was a really like fantastic overview of like all the different like steps in development and the features there. So that was really, really fantastic.
Yeah, thanks for inviting me again.
Yay. All right. Have a great day, everyone.
Bye.